Welcome all dear children. Today we will be doing the types of nucleophilic substitution reactions and their mechanism of chapter haloalkanes and haloarenes. So the first one whose mechanism we are going to discuss is bimolecular nucleophilic substitution reaction. Children, we represent this by SN2, substitution nucleophilic. 2 is bimolecular. So it is bimolecular substitution reaction represented by SN2. Now children, firstly I would like to tell you what exactly bimolecular nucleophilic substitution reaction means. Here I'll take one example, and with the help of that example I am going to explain you. Here we are having the nucleophile which is going to attack on the reactant, and that too is from backward side. Okay, so here nucleophile and the reactant, both the molecules will be taking part in determining the rate of reaction. When the rate of reaction is determined by both the molecules, that is by the nucleophile as well as the reactant, then that is known as bimolecular nucleophilic substitution reaction or SN2 reaction. Here the rate depends upon both the concentration of the nucleophile and the concentration of the reactant. जो रेट होगा वो दोनों reactants के concentration के ऊपर depend करेगा. Now we are reacting CH3Cl with the nucleophile or the hydroxide ion. When we react this, it yields the product methanol, and Cl negative ion is being removed. So children, what happens exactly? Here the nucleophile is going to attack from the backward side. So this, when attacks from the backward side, what it does, it is negatively charged. It gives its electron to Cl negative. Cl negative will take its electron and will move from here and will yield the product. As you can see children, here a transition state is being seen. So what is here in the transition state, we'll have two bonds over here, one with OH and one with Cl. Though 5 bonds are there, and we know that carbon has 4 bonds only. But here in the transition state, to this carbon, OH negative and Cl negative are also attached. So total 5 bonds are there. So when these two are attached, then that is the transition state. And what happens? This Cl negative will say, I'll take the electrons from you OH negative and I will be moving out of the site. So Cl negative moves out of the site, and what is left attached is OH negative ion here. So the product form is this one. Okay children, so hope this is clear to you all. Now these processes will take place simultaneously in one step. कि जो भी process होगा, this process is going to occur. This process is going to occur in a single step, and that too, how children? In a single step it is occurring, and that too with no intermediate formation. Okay, what we get is a transition state. So this is about SN2 mechanism. Now children, I would like to explain some more thing about this. So you can see Here it is a nucleophile and it is a haloalkane. Suppose here you have carbon and it is the halogen, so it is haloalkane. So this is how it is showing. Nucleophile with the electrons get attached to this carbon atom. Transition state is formed and final product is this, and the halogen on taking the electron will be moving out. Now what happens, children? Here the configuration of this carbon gets inverted. जो कार्बन का कॉन्फ़िगरेशन है वो इन्वर्ट हो जाता है. कॉन्फ़िगरेशन ऑफ कार्बन गेट्स इन्वर्टेड, उल्टा हो जाता है. जैसे कि when a strong wind blows, then what if you are along with the rain, then what happens with the strong blow of a wind? What happens? Your umbrella becomes your umbrella inverts. So when your umbrella inverts, so it is known as the inversion of umbrella. In the same way, here the carbon is being, or the configuration of carbon is being inverted. यहाँ पर जो कॉन्फ़िगरेशन होता है कार्बन का वो इन्वर्ट हो जाता है, जैसे कि अम्ब्रेला भी इन्वर्ट हो जाता है ड्यू टू स्ट्रॉन्ग विंड. तो इसको क्या बोलते हैं हम लोग? इन्वर्जन ऑफ कॉन्फ़िगरेशन और वॉल्डन इन्वर्जन. मैंने ऐसा क्यों बोला कि कार्बन का कॉन्फ़िगरेशन इज़ गेटिंग इन्वर्टेड? बिकॉज हियर द न्यूक्लियोफाइल इज़ अटैकिंग फ्रॉम द बैकवर्ड साइड. न्यूक्लियोफाइल बैकवर्ड साइड से अटैक कर रहा है, फ्रंट से नहीं कर रहा है, जिसकी वजह से जो कार्बन होता है उसका कॉन्फ़िगरेशन इन्वर्ट हो जाता है. उसको हम इन्वर्जन ऑफ कॉन्फ़िगरेशन कहते हैं या फिर वॉल्डन इन्वर्जन भी कहते हैं. और ये सिर्फ SN2 रिएक्शन में देखा जाता है. सो इट इज़ अ सैलिएंट फीचर ऑफ SN2 रिएक्शन. नाउ चिल्ड्रन, हियर we will be having the different types of halides and we'll try to understand in which type of halide SN2 reaction is seen in maximum number. So you can see here, children, in methyl halide we have 3 hydrogen atom, which is a small atom. Hydrogen atom is a small atom. So the nucleophile is having space to come and attach over here, over this carbon atom. But children, here CH3 is attached. So it is a bulky group. हाइड्रोजन से बड़ा ग्रुप होता है CH3, तो न्यूक्लियोफाइल को इतना इजीली स्पेस नहीं मिल पाता. तो इसीलिए मिथाइल हैलाइड में इजीली SN2 हो जाता है, क्योंकि उसको स्पेस मिल रहा है न्यूक्लियोफाइल को अटैच करने के लिए. यहाँ पर स्पेस मिल तो रहा है बट उतना नहीं मिल रहा है जितना मिथाइल हैलाइड ने मिला था. इसीलिए इसमें SN2 रिएक्शन होता तो है, लेकिन मिथाइल हैलाइड के कंपैरिजन में मुश्किल से होता है प्राइमरी हैलाइड में. In the same way, when we talk about the secondary halide, here also we are having 2 bulky group, 2 CH3 group are being attached. So children, as you can see here, less space is left as compared to primary halide and methyl halide. So this will be showing SN2 reaction but less in comparison to these two. In the same way, in tertiary halide we have 3 bulky groups. So now very less space is left. So nucleophile do not have proper space to attach over this carbon. So these tertiary halides will show SN2 reaction in minimum, like it would be minimum, or the order of reactivity of tertiary halides in case of SN2 reaction will be minimum. So the order of reactivity of methyl halide is maximum, then is of primary halide, then is of secondary halide, and the least reactivity will be shown by tertiary halides. This reason I have already told you, children, tertiary halide do not have proper space for the nucleophile to attach or attack over the carbon. So that's why it will be reacting least in case of SN2 reactions. So this is about SN2 reaction, children. Important topic from the point of your board exam. Hope this is clear. Thank you all and have a nice day.